We're now going to put together our p-test for improper integrals with the integral test to come up with something called the p-series test for the convergence of a series. Recall that the p-series test for integrals tells us that the integral from 1 to infinity of 1 over x to the p dx converges when p is greater than 1, but diverges in every other case. Recall also that the integral test tells us that if the integral converges, the corresponding sequence converges, and if the integral diverges, then the corresponding sequence must also diverge. It follows then that the series, the sum from n equals 1 to infinity of 1 over n to the p, is going to converge when p is greater than 1, but diverge in any other case. Notice, of course, that we still don't know the value of this series. We merely know, based on this p-test, whether or not the series is going to converge.